beginning, we wanted to use this project to explore and discover our own approaches to design by experimenting with ways of reading and representing sites.
And as we've moved through the project, our guiding question has continually evolved.
How can non-traditional means of analysis and representation of sight, recording ambient sound, video...
How can these thicker sensorial means of analysis, synthesis, and representation influence...
methods of analysis, discovery, and representation influence designers to create...
lead to contextually responsive design.
Immersion in sites and narrative-driven research unravel thick site... How can immersion and site-inspired research generate contextually responsive designs?
How do human scale, sensory, and somatic experiences influence design at all scales? We grounded these questions on the Tacoma Tideflats. The expanse of the site is remarkable. 6 square miles is challenging to traverse, let alone analyze or design for, at the human scale. In the Tideflats' many visual and physical barriers, something that could have halted our exploration, add a layer of intrigue and mystery as to how the site functions. The port is mostly designed for the trucks, trains, and ships that move thousands of tons of goods in, out, and throughout the site every day. To the visitor, it lacks legibility. Wayfinding cues are often non-existent. So how do we begin to unpack and analyze a site so large and challenging to access? We've experimented with many approaches to work with this, including video and models to understand the site's characteristics and processes at the human scale. Ultimately, the Tideflats became the testing ground we desired since the beginning of this exploration, to explore ways of experimenting with approaches to uncovering plural site narratives, distilling complexity down to legible threads, and then using video and model storytelling and site design to amplify those threads. March 14th, journal entry. Where do we begin in explaining our relationship with the Tideflats? We want to balance sharing our approach to reading the site with stories of shaping, material, industry, and change, as well as explain how we have experimented with these site processes in model making and generating design ideas. Maybe we start with the small scale and how much larger narratives are ingrained within. A restored beach overlooking this active port speaks to the pride and the productivity and economic gain industry has provided, as well as the shifts in how shorelines function on the site. Creosote-soaked wood piling remnants that once held up docks and buildings share how the port came to be and how quickly it has developed and changed. As the Tideflats have shifted politically, economically, and spatially, the historical narratives have compiled and abstracted, often blurring and hiding pieces of the past. Initially, we didn't read the site in a tidy chronological storyline. Instead, it was a process of learning about the past and speculating about future potential, by first immersing ourselves in the present.
There are infinite ways a person could experience the Tideflats. You could drive from the rail yard to the transfer cranes to the ship docks to glimpse the global shipping cycle that pulses through the port. You could follow the high tide line from when the site was a shellfish-rich tidal mudflat, an important food-gathering place for the Puyallup tribe, to get a sense of the recent natural and cultural history of the space. Restored beaches look out on industry from a quiet, safe distance, and you can find washed-up rusted car fenders, tide-worn timbers, and crab shells after every receding tide. For a watershed-scale view, you could drive down the Puyallup River from its headwaters near Mount Rainier all the way to its highly channelized terminus cutting through the site and depositing sediments into Commencement Bay. You could drive to the end of the train tracks on the Blair Waterway, where container cranes load 220,000-ton ships with goods bound for international waters, but security might kick you out if you try to film from there. Since all these experiences are possible within this dynamic site, we needed to prioritize the most influential forces shaping the space. We could allow what we found by walking the site over and over again to determine the direction of our designs. Identifying central storylines would give us something specific to respond to in our spatial designs. Streamlining, fabricating, and extracting emerged as the 3 driving threads.
January 14th, Instagram post. This site is a lot to take in. The Tideflats span a spectrum of scales both spatially and temporally. Gentle ripples of the tide meet the steady deposition of metal scrap created by our consumer culture. In the background, Mount Rainier's stable presence looms, which once paved these flats through a massive volcanic event. The Tideflats have been shaped for a variety of purposes, driven by the need to move goods. Food, wood, and metals, for example, have influenced how the flats function. From Coast Salish tribes such as the Puyallup, to railroad workers, to mill workers, to ship workers, all settlers have pushed the flats to be more productive. But once it was conceptualized as a port, it became a story about streamlining how efficiently products move in and products move out of the site. As shipping and manufacturing industries expanded, the soft shorelines of the Tideflats were channeled and armored to accommodate linear waterways, railways, and roadways. Productivity of this landscape was increased by engineering a new one. When rails met sails in 1873 with the completion of the Northern Pacific Railway, the Tideflats would transform at a much more expedient rate to accommodate booming timber and agriculture industries. The streamlining production meant a disintegration of many interests. In 1854, representatives of the Puyallup tribe were pressured to cede land claims through Washington in exchange for an 18,000-acre reservation on the Tideflats. By 1934, this reservation was piecemealed down to 33 acres as the flats were developed for industry. And in November 1885, 200 residents were removed from their homes and transported south during the Chinese expulsion, that would later become known as the Tacoma method, setting a forceful trend along the American West. Meanwhile, salmon and shellfish populations, the livelihood for many, dwindled as rivers and creeks within the White and Puyallup watershed were armored, diverted, and piped. During this time, the Tideflats were continually reinvented and reshaped to accommodate more products and larger machines. The Tideflats today have a clear purpose, and that purpose is extremely efficient. A global gateway for products serving as a livelihood for thousands of workers. Longshore workers, freight forwarders, steamship agents, machinists, and engineers are only a few examples of the diverse and skilled workforce found on the Tideflats. In all, over 29,000 jobs are related to the Port of Tacoma's activity. These workers process between 9 and 13 million tons of cargo through the port, totaling over $50 billion in trade with countries around the world.
The site is already functioning efficiently for the processes that feed the global import and export of lumber, vehicles, molasses, and containers. But in order for the site to continue to evolve and be resilient, it, like so many urban waterfronts, will need to provide more public space and opportunities for multiple uses. Future designs should invite Tacoma residents to see the sights and hear the sounds of booming industry and find calm moments of refuge. The Puyallup River has been streamlined and channelized. Over decades, its meander through the site has been erased, which makes it a potent location to intervene to complement and push against that streamlining in a way that brings evolving, dynamic, human and animal habitat spaces back into the flats without slowing the industrial flows. Wooden stairways and ramps made from the lumber moving through the port's mills invite visitors down from the riverbank to the water, and wood and salvaged urbanite pathways, decks, and reconfigured shipping containers combine in a loose fashion to float on the Puyallup River as its level rises and falls with the tides. These infrastructural components create a slow, zigzagging river walk with spots to stop and fish, birdwatch, or watch a giant metal claw crush a used car. Docks and decks jut out from the banks at angles to act as large woody debris, and over time create new riparian habitat niches for beavers, migrating salmon and trout, and wading birds. As sediments accumulate in small nooks and crannies, the shoreline will wander a bit. Carex, scirpus, and other wetland species may establish themselves on the banks and restore critical wetland functions. Tacoma metalworkers could cut large windows and doors into decommissioned shipping containers to create bird blinds, fishing huts, and lunch spots for port employees or cyclists following the Dome to Defiance Trail. The Riverwalk stacks more functions into this precious urban waterfront space by building flood resilience to protect adjacent businesses, inviting tourists and locals to linger longer in what often feels like a private space, and creating more diverse habitat. Drawing people laterally across the flats and riverbanks provides a more human-scale cross-thread to the strong linearity of the existing shipping channels.
February 12th, journal entry. Considering processes of fabrication and deconstruction, materials are experienced on site as a big homogeneous mixture of life cycles. It might be impossible to entirely separate a material from other materials to tell its individual story without telling a portion of another material's story. Maybe video can capture the speculation and mystery that we ourselves experienced when we first discovered these different scenes.
Research in the utilization of wood has developed plywood, end-matched lumber, wood briquettes, lumber patches, fabricated beams and trusses, preservatives, improved finishes, fireproofing, and chemical pulping processes. All of these developments have resulted in less waste of the forest.
That which is manufactured on and shipped through the flats is in constant flux, changing as the world's needs change. Timber has been used to build cities and ships, and steel became an important commodity for the same construction. And products we see every day, manhole covers, screws, butcher paper, aluminum cans, automobiles, are all pieces of the Tideflat story. From a single vantage, it is possible to see the birth and death of an everyday Kia, crushed, compacted, and deposited on a mountain of metal only a short distance from thousands of imports freshly driven off of a ship from South Korea. We see the end product, but the flats see the entire life cycle of these products unfold, from material to product to scrap to building material again. And the flats themselves have been fabricated, crafted from the same materials and processes often found on site.
Skilled craftspeople, engineers, and blue-collar workers have always brought great pride to the Port of Tacoma, and much of their handiwork is visible here. Within one small corner of the Tideflats, several stages of the life cycles of wood and metal that are often invisible are exposed and raw. Cycles of mining, processing, shipping, and sales often take place across thousands of miles, and as consumers we may never see them. Processes that have been externalized from most urban centers here could serve as an outdoor classroom where the stops better connected and identified. After you walk past Metal Row, along that same stretch of 509, you enter the wood life cycle zone. You can see lumber trucks roll into a distributor lot with huge, freshly harvested Doug fir and cedar trees. On-site mills process those trees into timbers and boards, and paper pulp mills chip wood into sawdust to be turned into corrugated packaging at the famous Kraft paper mill. Almost the entire material life cycle of wood is visible here. The only steps missing are the planting, tending, and harvesting of trees. Our design for the materials loop is to repurpose a defunct railroad track as a footpath to better connect these adjacent stops along the life cycle, give visitors a safe place from which to view the stops, and draw visitors from stage to stage with strategically placed educational shipping containers. The design also inserts the missing stage, the growth of trees, through a series of test plot forests. An initial test plot is planted along 509 to buffer visitors from thunderous truck traffic, and future test plots expand to fill in lots that are currently used to stage thousands of cars. These test plots are seeded on phyto and myco-remediated dredged sediments, which will be explored in the next design intervention. Test plots serve as demonstrations, small areas to test sustainable forestry practices, and as a local sustainable wood source to continue to feed the chippers, mills, and workshops that create jobs and craftsperson pride in the Tideflats.
February 15th, journal entry. An interesting conversation from our boat tour today. What seems toxic on the site may be rather benign, such as the paper mill or gas storage tanks. But there are far more insidious things at work elsewhere, such as stormwater runoff or remnants of arsenic and lead spread over 1,000 square miles from the now absent aluminum and copper smelter plants.
The ore mixture, now called calcines, goes to the great furnaces, where for the first time it becomes hot enough to melt. The slag is waste. It is hauled out and dumped. The molten mass cascades down the side of the dump like lava from a volcano.
Historically, the Tideflats have relied on extractive processes. Firs, cedar, and poplar have been cut to be used in products from paper to ridge beams. Copper, iron, and aluminum ores have been mined and smelted to assemble metals present in telephone cables or I-beams. Fish have been caught and grain has been harvested to fill markets and restaurants. Surroundings affect the flats and the flats affect them, acting as a global pinch point thriving on imports and exports. China, Japan, and South Korea are leading trading partners as the Pacific Ocean is bridged through regular trade. Every year, the port handles 183,000 automobiles, consisting of Kias, Mazdas, and Mitsubishis, 42 million board feet of logs, and 3 million tons of grain, amongst other products such as electronics, toys, plastics, aircrafts, and furniture. The past has shown that even the most stable of industries, such as the Flats copper and aluminum smelters, succumb to time, circumstance, and trends, leaving behind their legacy in both positive and negative light. The activity and productivity of a port that relies on extractive processes has had its consequences, leaving behind toxic legacies. Since 1983, the Tideflats have been part of the Commencement Bay Superfund site, a massive cleanup to counter nearly a century of industrial waste entering Commencement Bay, consisting of smelting slag, chemical spills, industrial fuels, stormwater runoff, and dumping of other excess. How does a port continue to expand and embrace its role as an economic generator while acknowledging its past? How does it balance productivity and serve as a place to inhabit?
Extractive industries have long provided economic income for the port, but those extractions and the resulting takeover of the Tideflats as an industrial port have come at the direct expense of the land rights, fishing rights, and economic survival of the Puyallup tribe. This design reimagines the now necessary extractive process of dredging as a generative process that can be harnessed to provide income for the Puyallup people today. This design posits a future scenario in which all sediments that wash down the Puyallup River and eventually have to be dredged out to maintain shipping channel depth are legally respected as the direct property and land of the Puyallup tribe. In this scenario, dredged materials are processed on the former Puyallup Casino site. The sediments are phytoprocessed and used as the Puyallup Tribal Dredge Management Association sees fit, with potential ideas being to nourish important eroded fishing sites around the Puget Sound or to export for income. Dredge dropped off by flat barges moves through a series of processing stages. Microtopography helps the sediments dry. Cattails and reeds perform rhizofiltration to help stabilize pollutants. Willows and poplars phytoremediate the dredge by degrading diesel and other industrial byproducts like PAHs. Mustard and miscanthus phytoextract inorganic industrial pollutants like palladium. Certain metals like copper can be phytomined, and then the plant material can be incinerated to recapture the metal. The Dredge Lab is a lucrative business that generates income for the Puyallup tribe and creates research positions as the facility tests different processing techniques. The former casino could house the dredge business operations, and the entire processing facility could serve as an industrial park where visitors learn about the research being performed, the ecological processes unfolding at the site, and the natural and cultural significance of the land. Across the site, in plain view from downtown Tacoma, a barrier island created off the tip of the Theophos waterway creates multi-level habitat that is inaccessible to people and restores some of the niches removed by the creation of the port. Over time, dredged sediments are added to the island to build a hill, and the island is left to be inhabited by plants and animals. The island repurposes the idea of dredging as another form of land building, this time for the exclusive benefit of shore-nesting birds, barnacles, seaweed, ospreys, and other animals whose habitats have been disturbed and fragmented. The island is visible from Theophos Park and helps visually connect the port to the strong greenway that extends all the way around to Point Defiance Park.
After 3 months of site explorations and research, we've only tugged on a few of the tangled threads that knot together the identities of the Tideflats. There's no way to uncover all the stories, but we've attempted to give legibility to a few of the main threads while not allowing any of them to dominate the story. There is no master plan that would ever be appropriate for such a dynamic place, so we've explored the seeds of designs that come from the materials we found, saw, and manipulated, the processes we've glimpsed and then dug deeper to understand, and the people we've read about and talked to at the Tideflats.
Letting the site drive the designs means the ideas operate at different scales and serve different purposes, from submerged wooden posts that provide anchor spots for tiny barnacles, to yellow shipping container classrooms that aid wayfinding, to massive dredge processing facilities that reshape the land itself. Visit after visit, objects we found on site and people we met directed us down different paths of research and design iteration. A section of rope washed up on the beach moved us toward unraveling the linearity of the shipping corridors and bringing finer-grained, smaller human spaces into the mix. Routing, chiseling, and sawing apart tide-washed timbers focused our attention on the massive land and water-altering processes of dredging, channelizing, and armoring. Small scale always led us to large scale, and vice versa. The balance gave us an approachable way in to an overwhelming, barricaded, complicated site. The project gave us ideas for how to move toward design from a human-scale, embodied place rather than from a predetermined program. Although the approach was at times terrifyingly ambiguous, it was reassuring to learn that investing time in understanding a place can be an open-ended and generative process.